Hello, everybody. It is March 28th, and this is the OLM Dev and Working Group meeting. Super excited to have our meeting at our new time on Tuesdays at 11 a.m. Eastern. In today's meeting, we're going to have a short discussion on OLM V1 upgrades and the experience associated with that, led by Todd. We're then going to talk about the OLM V1 releaser ideas. So if you've been paying attention, that is our strategy in terms of how we cut releases of the OLM V1 components and then release them to the world. And finally, we've got an announcement by Anik, it looks like, regarding V1 upgrade channels brainstorming sessions and something about a meeting host volunteer list. So not as familiar with this one, but we'll cover it in real time live. With that, I'm going to hand the meeting off to Todd and stop sharing.
Okie dokie. Hi, I'm Todd. I am probably the newest, well, okay, I'm no longer the newest team member, but I am certainly the newest Red Hat team member on the OLM team. So I was asked to look at OLM V1 upgrades user experience, and based on things we had learned from OLM V0, which I really was not significantly involved with, but let me share hopefully this will let me share my window. Why is, okay, apparently I do not have the share settings. Alex, can you go back to that document, that the agenda, and then click on that first document that I have linked there? Probably never enabled Zoom screen sharing on this machine. Okay, so the link in the document is a HackMD doc, and I'm just going to give you 10,000 foot overview here. So one of the things with OLM V0 is there are many pieces going on and lots of APIs to deal with, and I wanted to simplify things. So can you scroll a little bit, please? So the goals were here is, so yeah, that right there, perfect. So the idea here is that the operator CR, which right now only specifies the operator name, we would add a version to, and then OLM, or the operator controller, which is the current name of the repository for OLM V1, would attempt to install that version. Now, it needs to recognize whether or not what version is currently installed, and if it has a older version, it will attempt to figure out a route. So that is why operator controller is pointing at route, to figure out how to get from the current version and figure a route to get to the destination version as defined by the operator CR. So no subscriptions, no CSVs, no install plans, everything is part of the operator CR. Now, as part of that, what we need to, one of the other things is that operator controller will not install dependencies automatically. All operators installed, regardless of whether they are explicit operators to be installed or dependencies needed by other operators, need to be explicitly specified. And that is where that generate process comes in. The generate process for really simple operators is, virtually nothing. For a simple operator that has no dependencies, you don't even need to go through the generate process. You just define the operator CR, specify, which means you specify the name and you specify the version, and that's it. However, for more complicated operators, the generate process, you input into the generate process what operator and what version you want, and it will spit out the set of operator custom resources that you need in order to install that. So it will figure out the dependencies that are necessary, and it will figure out what versions they should be, et cetera, et cetera. And then it will be up to OLM, or the operator controller, to figure out how to get from the current state into the destination state or destination version. So that's kind of the idea. The idea here is that there is basically the idea of a destination is where you want to be, and that is determined by this generate process, and then how you get there is determined by the operator controller. It has the logic to do the installs and figure out what version comes next in order to get you to destination version based on the manifest of the various operators. Okay, can you scroll a little bit more until the next diagram? There's one other diagram in here. So also you can see here, there's lots, I've added comments based upon our feedback, the original document. Okay, so the generate command, the idea behind this is that it is something that can be run off cluster, or it could be run on cluster, or it could be run in the word is escaping me, so I'm gonna have to search for it here. Or it could be run as a process, an automatic process off cluster, or it could be part of the, I'm going to butcher the name here. I'm going to say control panel, but I don't think that's the proper name of it, because I have never actually used it. But the idea here is that the generate command will take in the current cluster config as necessary, what the current configuration operators are, and the desired configuration, and it will generate the operator CR. So it takes all these inputs and spits out what it needs. And my thought process here was, I was thinking GitOps. You can see in that paragraph right below that, it says GitOps. The idea being is that the current config would be stored as operator CRs either on the cluster, we can go grab them from the cluster, or we can grab them from the Git repo. And then we could feed them into this generate process, which, hey, it could be invoked by a make command. And you take the desired configuration that you want. So you want to update Prometheus from, and I don't know the current version numbers for Prometheus, but let's just say, from version 1 to version 2. So you say you want to update to Prometheus version 2. You enter that in along with the current set of operators, and it will go off and generate the set of operators, and that will be put into the operator custom resources, and that would then be used as a PR, a pull requests, and everything gets approved through the Git process, and it gets submitted and committed into Git, and then it gets pushed to the cluster. So the idea here is this generate process can be, as shown in the little diagram, the little example below, could be it could be just a command line tool, or like I said, it could be a process on the cluster itself. So this is the thing that determines whether or not there's an upgrade available, and if so, updates the operator CRs to have operator controller install those updated operators. So fundamentally, there are two pieces to this. Instead of having one big, massive chunk of functionality, it's split into two. One that is always on cluster, which is the operator controller, and then this generate process that could be in a number of different places depending upon how you want to manage your cluster. And that is fundamentally it. This is a fairly long document, so I'm not going to ask us to go and comment on it right here. We can talk about it next week. And that is all I have for this introduction. Any quick questions?
Not so much a question just yet, but more of a just thank you for preparing this and presenting it to the community. I really like the idea of having basically having a component that can figure out what upgrades exist based on inputs and, gives you the outputs, where the output is the stuff that needs to be installed. I think that makes it, it offers us this new experience where, from a dev standpoint, it's much faster than having to set up your cluster and install everything. This offline aspect is really great. And then finally, the ability to automate that to cover these different workflows that you've kind of mentioned. One was like GitOps, one could be just somebody wants something on cluster that happens all the time. One could be just a cron job that runs periodically, whether, ultimately we go in. I think it opens up some really interesting discussions. And, what's really cool is it offers us this ability to offer simplified user experience where upgrades are, you just run this tool and you see the upgrades and you initiate it yourself. And then we can go as far as like making that more automated as we see fit. So I'm really excited to see the conversations that this creates. And thanks for submitting this.
So I had two things. So one, it is kind of to expand on Todd's point about how we're not going to auto install dependencies. I think there's some context there that's maybe important to say why we sort of think that we should do that. But essentially what it comes down to is the uninstall experience. So if you think about it, there's this scenario that we've constantly struggled with, which is, say you install operator A, and operator A depends on operator B. And if we did auto install and we're trying to be declarative, then that sort of necessarily means that we're going to do auto uninstall, such that create A causes a bunch of stuff to happen. Delete A means a bunch of that stuff gets undone and deleted. So that would mean that operator B then gets deleted when you delete operator A, if nothing else depends on it. So what that also means is that it's possible that on your cluster, you could have said, I really want operator A, the APIs for A get installed. Because A depends on B, the APIs for B get installed. Now, all of a sudden, your cluster has this new API that theoretically anyone with RBAC can go and start using. There's no real linkage that says, oh, like you can't use this user because you didn't declare your dependency on it. And so we want to be really careful about then going back and deleting stuff that non-declared dependers might be using. So the idea essentially is like, all right, well, then we're just not going to auto install or auto uninstall dependencies. If you need something, then you have to tell us you need it. And then if you decide later that you don't need, so let's say, okay, so let's go back to the scenario of A and B. If you say you need A, then what's going to happen is the on cluster reconciler is going to say, can't do anything. A needs B and you didn't tell me you needed B. Please go and create B. So you go and create B. All of a sudden now the resolver says, great, looks like everything's good. I'll install A and B. If later you say, okay, I don't need A anymore, then you can go and get rid of A. B still sticks around. So I think there's this second level question we need to figure out about, like, should we tell the user that they've got this unused dependency still on the cluster that they might want to also go and clean up, which raises some question about how do we tell whether B was originally wanted or not. So I think there's some stuff in the doc about this used by concept, which we might be able to figure out something along those lines. The other point I want to make is that, and Todd, correct me if I'm wrong, but I think we've talked about this a little bit, so I don't think I'm putting you on the spot too much, but Generate is essentially like this helper tool that makes it easy to produce a valid operator CR set. The operator controller makes no assumptions that Generate was used, right? So like the operator controller still has to have the same sort of resolver logic that we expect to live on cluster to tell you, hey, that set of operator CRs that you have, somehow you came up with it, that's not going to work. I'm not going to progress, right? Like, so Generate, I think in my mind is more of a tool that makes it easy to consume the operator API. Is that right?
Correct. So Yes, it is always possible for any user to go off and create an operator CR, and subsequently also possible for an operator to make a mistake, for a user to make a mistake and not have the dependencies defined, et cetera, et cetera. So operator controller has to be able to handle those conditions. Also, so what this means is that there's going to be actually a bunch of common code between the operator controller in terms of reconciliation resolution within both generate and within the operator controller. They'll both share a bunch of common code, but and we also recognize that those may not progress in lockstep. You may have an operator controller that's slightly older than generate may be a little smarter, or vice versa. And we have to be able to handle those type of conditions.
Cool. I'll just unmute myself here with another question for you, Todd. So that at a high level, this reminds me a lot of requirements.txt for Python stuff, or go.mod for Golang stuff, right? So it seems to resemble some ideas from that area, where you basically have a declarative list of things that somehow belong together and a kind of version together, and that's what you get when you install it. So I think that part, unless that's not correct, that part tracks for me. It is obviously a departure from what OLM v0 was doing, where it was resembling the behavior of classic package managers, where as a result of the declarative install of a thing, you also got a bunch of other things potentially installed or updated, and maybe or maybe not removed, right? So I think that's just important to call out, that where OLM was very much leaning on operating system based package managers in OLM v1 when it comes to the actual UX, it's now more akin to language package managers, which have some sort of requirements.txt equivalent, where they track your dependencies of your project.
Yeah, yes, you could say that. But also, if you look at it as a whole, it is very similar to, you look at the two pieces together as a system, it is similar to a package manager.
Right. So the thing that maybe it's covered in your document, I just need to read this, but during updates, this is something where previous OLM v1 had a behavior where it would essentially update in lockstep if an update was deemed required. And that was the reason why we resolved in namespace scope, and also the update policy in the namespace was kind of the same across every operator namespace, so that this could be done. So how do upgrades work in this world where, let's say, the thing that you actually care about has an update, and all the dependencies that got generated as well alongside the initial install now also need to update in order to satisfy this new version? So this is typically something that you have in like larger packages or package groups, where if one package updates, that means a bunch of others also need to update in order to be in the resolution set and also be considered supported and working well together. How is that done with the generate approach?
So the generate approach, a generate would have the logic to know based upon the various inputs. So as an example, just the A and B example. So you want to go to A version 2, and you are at A version 1. A version 1 uses B version 1. In order to go to A version 2, you need B version 2. So the generate code would have that logic based upon the catalog sources and manifest and everything, in order to determine that, okay, if I want to go to A version 2, I need B version 2, and it would put them both into the output operator CRs, which are then placed upon the cluster, and then the operator controller would look at this and say, okay, I need to update A version 2. And it goes look, it's like, okay, in order to do that, I need to also have B version 2. Oh, look, we also want to install B version 2, so we're good. However, if a person were to just update, operator A to say version 2 without updating operator B to version 2, the operator controller would say, yeah, this won't work, so I'm not going to do it.
Okay, and it doesn't sound like there is, like, from a UX perspective, there is like a static manifest list, or like just a list somewhere that is the output of generate that you then further modify. You're actually executing the generate logic again and again every time you modify any of its inputs.
I am trying to grok what you said.
Yeah, maybe
So-
walk us through how that works in the cluster. So what is generate? Is it like a like I'm on a cluster and I'm doing GitOps, right?
Yes.
So,
So in this case, if you're doing GitOps, generate would be a command like kubectl operator generate, and you want to with options that would say you want Prometheus version or operator A version 2.
Mhm.
And it would go off and figure out that it also needs operator B version 2, and it would output the necessary operator CRs. So if you look at this diagram, it looks at the current config, which in this case would be operator A version 1, the desired config, which would be operator A version 2, that is fed into generate. Generate then says, oh, we need operator B version 2. So let's make sure that exists and is available. Yes, it is. And then it writes it out to the output, which can then be evaluated to make sure it's what you want. So one of the things we've done here is we've actually gotten rid of on cluster approvals. So the generate indicates what, it outputs what you want, and before you go off and apply it, you can review it and say, this is what we want, and apply it, or you say, oh, no, something's wrong here, and discard those changes or rework those changes. And in the case of the desired config, this is not well defined, and because this is a work in progress and we're looking for input, if you look at the desired config box, there's something listed as a manifest, and that manifest would literally be, like operator A version 2, operator C version 3, operator D version 4, for example. And I'm excluding B there because once that's fed into generate will know that operator B version 2 is necessary for operator A version 2.
Yeah, that all tracks. Do you foresee there will be multiple instances of that manifest on the cluster, or in Git that would need to be evaluated together? Or do you foresee there can be, for a cluster, only be one canonical manifest?
That is a good question. I don't want to say it's up in the air, but I would say it is something that it could be, depending upon how we define how the manifest is, we could be a single entity or multiple entities.
Right. And the question, or the reason why I'm asking the question very specifically right now is, I'm wondering, what do we do with shared dependencies that create conflicts? So in your example of A and B and B1 and B2, let's say there is an independent party that's also using a cluster that wants to have operator C, right? And maybe version 3. And that thing requires B version 3 as well. So if they put in that into generate, that would obviously resolve, right?
Yep.
And it would say, yeah, you'll get C3 and B3. And now B3 and B2 on the cluster, they would collide, right? Would you resolve that at the generate phase, or would you resolve that at when you apply to the cluster phase?
So generate can do that if it has the data. If it doesn't have the data, then the operator controller will say, wait a second, there's a conflict here. I can't reconcile this, and will throw up its hands and indicate that there is a problem. It'll do as much as it can, but if there is a problem that is a conflict, it will not put the cluster in a position where there is a conflict. It will say, I can't install these three versions of operators because, operator C depends upon one version of B that operator A is incompatible with.
And that information that it requires, that's on the cluster, right? So generate would not just work in isolation. It always needs to work in the context of the cluster.
Right,
make
and
that
so
call.
right, so one of the options, certainly because it can be used as a command line tool. One of the ideas is that you can go off and grab all those operator CRs and feed them into the tool in a single in a single swipe. So I think there are examples in here of this. I'm not going to have Alex scroll, but or you could have, and this kind of goes to Joe's point in that, if you have two people competing here, operator controller is the final traffic cop and makes the final decisions.
Okay, thanks for answering my questions.
So one
Yep.
one thing that you mentioned, Todd, that I'm not cutting anybody. I saw Alex hand up and then it went down. One thing I want to call out is that there sort of still is an approval on the cluster, right? Like when you specify a version, you're saying, I approve the cluster to automatically upgrade as necessary and take whatever hops necessary to get to my desired version, right? So we're basically saying, like, I approve whatever you need to do to get to this state, right?
If that's a question, then yes.
Yeah. Okay, I just wanted to call that out to make sure that was understood. So I
Right.
think there's something that maybe we should still talk about there, which is the desired version might be multiple hops away from the current version. So you sort of are implicitly approving other versions to be installed, as long as A, they're on the way to your desired version and not, somehow greater than your desired version, and B, they still, like, each individual step is still, like, not in conflict with, like, the whole cluster's state at the same time.
Yep. And I was just going to say, in terms of GitOps, where you have a very explicit ownership model of the cluster, where it's like, okay, the GitOps people are the ones who are in charge and everything goes through Git. It's less of a problem because in terms of the conflicts, because everything will go through Git. Basically, when you do have these multiple users, this is where operator controller needs to be able to deal with these conflicts and be able to figure out how to get operator from the current version to the desired destination version. And you can specify those steps individually if you want to. If you are smarter than operator controller, you can specify exactly which version you want to have it update to, and it will try to get to that version. And then once everything is settled and everything's happy, you can specify the next version you want it to march to. It won't automatically go to the most recent. You, the user, are specifying exactly which version you want.
Yeah, so I think that's the observation that I was making, and it seems like essentially what we are saying is that in today's world, how we have the automatic approval, that is not going to be the case in V1. So everything is just going to be manual approval. And also one of the things that you said, Todd, was, after you see the operator CRs that are generated, if you see that there's something wrong, then you can choose not to apply. But then I think I want to have that assumption that users usually are not that aware of the OLM internals or dependencies. And, if the operator CRs, or if the output of generate says, operator A version 2 requires operator B version 2. Is that correct or not? I have no idea of saying that. I have no idea of knowing if that is correct, true or not. But then in V0, that all of that is automated. That's the install plan and the dependency resolver. They all do these calculations and then just apply the install plan, saying that I know this is the correct configuration, apply that. And if you want to keep applying it automatically, I can already do that. But we are saying that in V1, it's not going to be like that. It's you do this manual generation and you do this manual apply every time you need to upgrade. And it sounds like we are all okay with that.
So let me clarify is that this generate process can run. The intent would be that there would be an opt-in process on the cluster that would be the equivalent to generate, so that it will automatically do these updates on your behalf. So it's not, it really depends upon how you view your cluster. If you are a GitOps place and you want to know exactly, so I come from Akamai and we know exactly, hopefully, what software is on each of our hundreds of thousands of machines out in the network. And it's very precise about what version is here. And we don't want the machines to make any choices about what is installed. We want to know exactly when we deploy the software. So if we're in that camp and you want to know exactly what it is, you can do all your work off cluster to determine what you want on there and then say, here you go, here's the information, here are the cluster, the operator CRs, go do it. However, if you're in the camp where you want, okay, I want the latest versions of operators A through Z, you can have that too.
I think I think you give a really good example about the GitOps stuff, but I almost like when you say that, it's like, okay, if I'm building a thing that I want to know exactly what software is on my cluster at all times, I'm probably going to go write a thing that GitOps my Ruckpack bundle deployments directly, because then there's no controller that's going to pivot those or cycle the versions or do these routing things. Like if I want to know exactly what's on there, I'm just going to create like, here's the bundle deployments. The problem, obviously, like the extra complexity there from a cluster admin perspective is you don't necessarily have any guarantee that those bundle deployments form not a conflict-free dependency satisfied set. So that's like on you to figure that out offline. But in like the trade-off then is like, you know exactly what's on there, nothing is going to change. I think like if you step up to the operator API, that's where you're sort of saying like, all right, cluster, I trust you, you do your thing. I'll tell you some sort of high level requirements that I have for what I want to exist. And then you sort of figure out the rest for me.
Right.
So,
and that is something described here. May not be particularly well, but it is described here. And that is what I refer to as the opt-in on cluster generate process. I call this a component actually, because I'm not trying to define exactly how it's implemented. But the
yeah,
idea is that logic could be there to do that.
I guess what I'm sort of getting at is like, it seems like there's this, and you mentioned this, I think somewhere in one of our back and forths, like we sort of have this hybrid where it's not quite fully automated and it's not quite fully manual. It's sort of in the middle. But what I'm struggling a little bit with is that the operator API itself seems like it's straddling that line, right? Like the bundle deployment API is straight up, what you see is what you get, period. Like as long as they install correctly. The operator API without the generate command is what you see is what you get, except that some stuff is going to happen in the background to get you to your destination. With the generate command, it's okay, we're going to just continuously update your operator CRs as updates come out according to some extra policy. So I'm wondering like if the former of like, it does it make sense for the operator API to exist outside the scope of having an always on generate command, or or do we expect that cluster admins who want that guarantee, are they just going to drop down and use bundle deployments? That's what I wanted. Like, are we going to build some complexity that's people aren't going to use because they'd rather just define the exact images they want running?
Yeah, and to add a little bit to that also, if we define that operator API that is on this generate automatically all the time on cluster, I know Todd said that we are not trying to talk about implementation here, but at least the way that I'm thinking is that if you have some process on cluster that generates this CR, that means you need to show the output of generate so that an admin can approve or disapprove the output of this generate in order to be applied to cluster. And that feels like that's install plan renamed to generate. That's totally possible that I'm already used to the install plan approval process. That's why my head is going towards that. But I'm also struggling to see the difference between the output of generate, which is an on cluster API that says here are this output operator CRs that I'm going to apply. You have the permission to either automatically let me keep doing this application or approve this application whenever you want manually. And that sounds like install plan approval on cluster. And I'm not sure what the difference is between this and the output of generate and install plan.
Right. So at least in this case, I'm going to be quick because it's at 11:42 and we have other topics. But the idea is that we basically have mostly eliminated approvals. If you want to approve, you do stuff offline. Really, if you want automated updates, you do stuff online without approvals.
Okay.
I mean, read the document and I provide feedback. And you know what? I'm going to be very blunt. I mean, this may not be the approach we take. This is a fairly high level view of how to do things, and it may not be the approach we take. So I am willing to scrap this if necessary. This is what I'm trying to say.
Yeah, and I think that's a great approach to take to anything that we continue here, right? So I would say that rather than continue to raise concerns that may not be addressed by the document, let's all read through the document. Let's add comments wherever we can. I really want to visit back to that point that Joe made in terms of like, what is like the bundle deployments speak to what is being installed, whereas like what is the operator controller or operator API guaranteeing. I'd like to revisit those conversations on the document and also like pull it up probably on Slack. But like, as we share this document and add comments, whenever we're talking about design decisions or meaningful feedback, let's push that to the document so that we can really have a paper trail with whatever decisions we make and whatever concerns we raise. So Todd, thank you very much for introducing this to everyone. I think it's going to lead to very fruitful discussions, and everyone else who is participating actively, Daniel, Joe, and Anik, thank you very much for all your feedback at this first run through the draft.
Thank you.
Cool. Jumping on to the next thing. So Daniel.
Yeah, Alex, should we let Anik do his meeting announcement first, just in case the next discussion goes long?
I'm up for that. Anik, are you ready to do that?
Yeah, sure. It's going to be a very quick thing anyway. So tomorrow, again, I sent out an email in the OLM working group subscribers list. There's more details in that email, but we have been talking about what channels and what upgrade channels look like a little bit, very scratch initial conversations, and it seems like it's the appropriate moment to just get on a call and get a pulse of the entire room for what everybody's thinking about. So tomorrow we were thinking about meeting at 9 a.m. EST to just have a brainstorming session, free for all. And I just want to do that announcement again right now. The next point that can wait till the next meeting. It's not something important. The meeting host volunteer list, in the interest of time.
Sorry, could you, I'm actually unaware what this means. Could you just call out what this is talking about?
Oh yeah, I was gonna say that, okay, it's probably, it looks like it's, if we were having this conversation, Bryce, I don't know if he's in the meeting, but they have in the Opera SDK, they have a list where they can allow, or you can volunteer yourself to run some of the meetings. That's the working groups or the issue triage meetings, in the interest of spreading some of the workload that Alex, you've been doing such a great job of of running all of these meetings, if we want to start something like that, I think that sounds like a good idea, because then we can sort of jump in and help host some of these meetings.
Yeah, I would totally like to offload as much as I can. But like if anybody's interested in jumping on it, please just send me, maybe Anik, can you just update this agenda and just like point to a doc or something that allows us to track people that are interested in leading this meeting? And then Bryce, maybe you and I could sync just to see what the SDK team is doing, and or maybe even that doc, you can kind of just explain the SDK process, and then volunteers can, volunteer in line.
Yeah, so just one thing to note is the SDK, the process we follow is typically that it's maintainers only. So not just any community member can do that, because typically recording and stuff requires access to the operator framework CNCF account, or like having host keys to do that. And we don't want to just give that out to anybody. So just a heads up there that it is a volunteer list, but it's a volunteer list of like maintainers of projects that contribute to the overall sub project.
Yep, that makes sense. We currently use like LastPass to share the password, so we actually hide what the password is from people we allow, like when I switch it out to other people to lead the meeting. One thing I'll note there is that sometimes Zoom notices that you're jumping around the country depending on who's leading the meeting, and then they ask you for a to check an email for a 6-digit login code, and then they can't lead it. And so there's some issues there, but let's get a doc up, let's share it, let's get anyone who's ready to jump on this. Let's make sure that they have the creds, and then we can start divvying out leadership for the meeting. One other thing I think I'd like to shout out, Anik, great job, broadcasting, meetings that you want to have external contributors share, where, you announce it here, you announce it in the email thread. I think that's great. I encourage everybody who's in this community to take a similar approach. Like if there's something that you want to talk about, it's worth talking about. So, if people show up, I suppose. But blast it, use the OLM dev channel on Slack to promote your OLM v1 discussion topics. Send the messages to the email list, whatever you need to do to get your word out so that we can have these conversations. I know historically a lot of that comes from the maintainers, but I definitely saw some other contributors outside of the core group that were in this meeting, and I encourage you to do the same if there's something you want to talk about. Okay. And I see Todd, Tony, you have a hand up. Is there anything you want to talk about before we hand the meeting off to Daniel?
Yep. Just a quick question to Anik. So for tomorrow's meeting, do you have anything that you want to share so folks can read before joining the session you have tomorrow?
Yeah, I saw the email, saw one of the replies in the email.
Yeah.
Fortunately, it's just very bare bones conversation that we just started having. There are a lot of conversations that's just all over the place. So I was thinking about compiling a list of that, so that it gives a sense of what we are going to be talking about and sending it out. But there's nothing concrete yet. The meeting is just so that we can come and have a ad hoc, free flow conversations, so that we can come up with something concrete after the meeting. But just to get a sense of like what the meeting is going to be about, I can compile some of these conversations and send that out.
Yeah, I think that would be helpful. Thanks.
Perfect. Yeah. As we, when we do these meetings, try and make sure that you do whatever work you can up front to make sure that there's some guardrails in terms of what's going to discuss. What's going to be a discussion topic. Okay, cool. Daniel, do you think you still have time to get this OLM v1 releaser stuff in front of the group?
Yeah, I think so. So this is really more of a vibe check than a proposal or anything really. I wanted to basically kind of read the temperature of the room and see how people were feeling about the release process for OLM v1. And you'll notice I don't have like a doc or anything to share at this point, because basically what I want to do is, before I write that up, is get ideas from people, or wish lists or amendments to what I do have, which is really bare bones and simple for doing releases on the new version of OLM. So what I did the last week or two was take a look at some of our existing OLM projects in the operator framework. I'm also one of the newer members, so I was previously unfamiliar with them, and I'm also in kind of a newer work environment as when it comes to doing kind of public GitHub stuff. So this is all kind of fresh for me, and that's kind of why that background was necessary. But it seems like the theme for most of our existing projects is that we are pretty process light for our existing release processes, where we basically just have GitHub Actions set up so that we can automatically release our projects by simply pushing up a tag. And after doing some thinking initially of doing a little bit more process heavy, I've kind of changed my mind and would like to continue doing that, or something very similar to that, potentially creating a release branch off of main or master, and then creating and pushing a tag for that release branch in order to do the release. So that is super bare bones at the moment. There are finer details, of course, as far as what we do in the release process, but to make it easier for contributors, or really anybody, to come in and work on the project and do their releases, I think it's worth keeping it simple. But I wanted to give a chance for people to chime in and give items that they would like to see in addition to that, or if they think that that is too, I don't know, too process light, whatever. Joe, I see you've got your hand up. If you want to speak up.
The only thing on my wish, the root thing on my wish list is what you said, which is the release process should be push a tag. Like any other human effort involved in cutting a release is just room for mistakes to happen, which all of us make mistakes.
Sure.
So I think like we want to try to eliminate that as much as possible, so that A, we have fewer mistakes, and B, we don't spend a day or a sprint or whatever doing all of the little manual tasks that are required to cut a release. So we need to automate that as much as possible and have stuff triggered off of tags, in my opinion.
Yeah, absolutely. Vu, I think you're next.
Yes. Why are you laughing? I haven't said anything yet.
No reason.
Someone is nervous, apparently. Yeah. So from a release perspective, my recommendation, at least what I thought would be neat in my head, is having some sort of schedule in some way. Of course, really, it's never actually follow a concrete day by any means, but you guys should at least having some sort of like an idea of what the cadence should be.
Mhm.
And that's just not from the perspective like, you know, pushing a tag, things like that, but also allow you to set a proper milestone, and also allow you to assign certain feature that you're planning to do a certain releases that not the current one, or not even the coming up one, but potentially, you know, couple one ahead of time, similar to how community does in terms of like maturity level of a feature, you know, alpha, beta, and stable, and so on and so on. Essentially, when you know, OLM get to the V1 state, that would be good. And secondly, is the fact that there's a lot of things going on in OLM, of course, operating framework in general, which is good. But that involve in order to make people aware of all the work that you guys doing, all the feature and on potentially API changes that you guys can do in the future, there must be a change on a log, chain log, and any kind of announcement in
Mhm.
details on how things changing and how things been developed and all of that. And I think that's important part of the release process that I don't see with OM at the moment, of the framework at the moment. And I think that's a critical part that need to be addressed. And I think that's something should be important for the release process. And that's it. for
Yeah,
me.
definitely. Yeah, maybe we could, I don't know, maybe we could like automate a release email, including a change list or something like that out to the working group.
Yeah, I actually echo what Boo is saying there in terms of, it'd be nice if we did a little bit more publication on our own about like some of the stuff that we're doing. The
Definitely.
existing releaser script, I believe, does do a commit change log. And maybe we could leverage that and, whenever we cut a release, just do a quick little log update of some sort. I know CNCF offers some assistance in terms of getting in front of developers. I don't know what exactly it is that they offer off the top of my head, but they've definitely sent surveys out asking if we've used those services. I usually just say no, and maybe we should change that. And so that could be a great discussion point.
What was the name
So-
of that service real quick again?
OLM is a CNCF project, which is the upstream organization that governs Kubernetes.
Yeah.
So they offer some stuff. I can look at that after this meeting. Maybe that's a to do on my part, and we can go over that. So maybe we add that on.
Yeah, that would be cool.
For next Tuesday, and we can look at like what it is. I think at the crux of it though, like making it easy to push a tag and cut a release is awesome. There may be some benefits of pushing a tag and then cutting a release is great. It may make sense to also cut a branch for each major or minor Semver change of the release. Just so it's relatively easy. I don't think we have an official support statement on OLM right now. It's like just use the latest all the time, but there may come a point where somebody wants to use like an older version of our project, right? And to have the ability to backport critical CVEs on released content, that could be nice. So that's something we could probably weigh and consider. But otherwise, I mean, I think it sounds great what you're proposing, and as long as as we're making those changes, we've just when we get closer to actually committing to the release process, let's make sure we get in front of the community as much as possible. We get in front of the #OLM dev Slack channel, and then more importantly, everybody, as we always do, if we start working towards something and we cut a form of the releaser and we like it, but there's something that we think could be improved, we can always, iterate on the design and improve it. So, relatively safe right now to, try something, see if it works, and if it doesn't, change it at this stage in our development.
One other thing, real quick, that I'll throw in there is another thing that might help is that GitHub has shared organization actions, I'm pretty sure. So if we want to try to build some consistency, we might want to go take a look at that to see if we can have our repos all pull from the same shared actions and drive consistency that way. That, I think one of the struggles we have right now is we've got 8 repos that are sort of actively developed, and all of them have all of them sort of do this, but all slightly differently, and it's kind of hard to jump back and forth between the different ones and manage the releases easily, because you have to sort of keep track of how to do it for each one.
And is there any reason we wouldn't make this release process universal across all of the repos, basically? I mean, there maybe are some extra things when we do a big system-wide release, like maybe more announcements or something like that. But
I think by default, it should be universal, and there should be like a good reason why it shouldn't. And then, I mean, we should be able to make exceptions if we need to. Like, for example, some repos are libraries only, some repos are binaries, some repos have multiple binaries. We need to think about the variations to figure out like what makes sense to be universal, what doesn't. And we might be able to still centralize those things. But yeah, in my opinion, universal by default and exceptions where needed.
Vu, got your hand up.
Oh, I'm sorry. I thought it's
Oh.
supposed to be hands down when I finish my talking. But
Oh, no
sorry about
worries.
that. That's not my fault though. That's Zoom.
No, it's Zoom.
Okay, so I just had some notes that we said easy releases are important. Continuous release, frequent releases, easy and frequent, I guess is the best way to phrase that. Easy and frequent releases are important, and shared GitHub actions may be useful for managing projects in the order. Okay, so let's investigate that shared GitHub action. And overall, I think we're looking pretty solid. Is there anything we want to discuss before we conclude for today? Okay, well, Daniel and Todd and Anik, thank you for presenting in this meeting, and to everybody else. I really appreciate your engagement. And once Anik updates this with a list with the describing the meeting host volunteer process, I encourage you all to get involved if you want to lead this meeting. Okay, on that note, I'm going to conclude the meeting, and I will see you all next Tuesday at 11 o'clock Eastern.
Awesome. Thank you very much.
Thank you.